So guys, in this video let's look at the different types of variables we can create in Solidity. So we've seen string already, and in other programming languages you might know of int. So int, you just type it like this and then you give it a name here. But in Solidity we actually use uint. So you can see here that there's many different types of uints. The u in uint basically means unsigned. In other words, it can't be negative. So we'll use uint 256, which is the one we normally use. Basically the different numbers here is how big it is. So if we were using, for example, uint 8, we wouldn't be able to store a very large number in this. But uint 256 is what's usually used on smart contracts. So uint 256 is for when we're working with values like currency values and stuff like that. How much of coins you want to send from one wallet to another, those types of values. And you could use the smaller uints if you knew what type of numbers you're going to be working with beforehand. But usually in smart contracts we're going to be working with like sending values and receiving values, which could really be anything. So we want to use 256 for most things. And we just give this a name like my_num, and we set it equal to a number. Now one thing to notice here is that this is a full number. We don't have any decimal places here or anything. So in Solidity we actually don't support decimal numbers. So if you wanted to use a number like 25.3 or something, you'd actually have to do that by making an extra long number. So this is actually how tokens work. So if you've seen a token with a supply of, for example, 100, what's actually happening behind the scenes is it's doing 100 times 10 to the power 18. And it's using all the extra zeros as decimal places, but it's actually storing it as just a whole number. So in Solidity, when we want to work with decimals, we have to do it that way and make an extra long number. And then whenever we're reading that value out to the user, we have to basically undo this and give just a normal value back, since we're using the rest of these zeros as decimal places. But that's something we won't look at right now. So the next data type we'll look at is Boolean, so BOOL, and this is a simple data type that we can only set to true or false. So what we would use this for is if we're checking if something happened. For example, in one of the token contracts I made, there was some function I wanted to run only once. So I created a boolean at the top to say, is the function run yet, and I set that equal to false. And then only if that boolean was set to false can I run that function. And once the function is run, it sets the boolean to true, so it could never run more than once. And there's many other use cases for boolean to check if something is valid or not. But yeah, we'll look at this also more in further future tutorials. So the next data type we want to look at is structs, so struct, and this is basically a data structure. So let's create one called myStruct, and we just add our curly braces here and we say what kind of data goes inside this. So for this one we'll just give it a string of username, and we need to add our semicolon after each variable type here, and then we'll give it a uint 256 of age, and we need to add the semicolon there as well. So now that we've created our struct, we can use it by creating a new variable, and this one will be of type myStruct, which is what we just created, and we'll call it, let's say, Theo, and we'll set this equal to myStruct. So we're creating a new structure, a new instance of this, and now we add our normal parentheses here, not the curly ones, and inside of here we pass the values that we wanted to store. So we pass a username and an age. And if we save this, it should compile correctly. So this is how we use a struct. We basically define it up here, and we say which variables it holds, and then we create an instance of it here, and we set it equal to the instance of the struct we created with the correct values passed in. So this may not look that useful right now, but when we're doing things like attaching data to accounts, then this may be useful there. So for now I'm just going to remove this, and the next data type we want to look at is lists or arrays, and this is done the same way it is in C#. So for example, if you had uint256 and you wanted an array of this, you could just add in your square brackets here and then give this a name, nums, and then you'd give it some values, so 2, 5, 7, whatever, and that's how you'd create an array. So the last data type we want to cover here is called mapping, and we need to give some parameters to this before we create it. So this is basically an associative array, if you've ever worked with that in a different programming language, and it's basically an array where we map one type of data to another type of data. So we'll map a string value, and we use a equals to and greater than sign. This is similar to a lambda expression in different languages, but here we're just using it to associate one data type with another. So we're using keys as a key here, strings as a key here, and for values we want to use uint256, and we'll call this mapping balances, for example. Now that we've created it, to actually use this, it needs to be done inside of a function. So I'm just going to create one here quickly. And I know I haven't covered how to create functions yet, but we're going to look at that in the next video. For right now, just type what I have here, and we're going to use the mapping we just created, so balances, and we use it in the same way that we use an array. So for a key here, we put in our key, which is a string, and I'll just give this my name, which is Theo, and we'll set it equal to, let's say, 250. So as you can see, we've created a mapping called balances, and it's basically an associative array which maps the string key to a uint value. And here we're giving it a string key of Theo, and we're giving it a value of 250. So this becomes more useful when we use it combined with structs. So we could have a struct that holds usernames and bios and stuff like that, and then for a key we could use account addresses. So basically any account that interacts with this contract could have its own username or bio or whatever, and we could use this smart contract to run something like a social media or something like that. But we'll look at that more in future videos. For now we're done looking at variables, and in the next video we'll look at how to create functions.